In this playlist, I'm going to show you how to create a CPU.
Oh boy.
Let's start by understanding how electricity works. If you use wires to connect a battery to a small light bulb, you can illuminate the light bulb. It's what we would call a simple electric circuit. The battery acts as a power supply, which means that the battery supplies electricity to the circuit.
Power!
As an analogy, if electricity were like water, the battery would be a pump. Electricity has to flow in a loop, or circuit. So, if we disconnect either of the wires between the battery and the light bulb, we break the circuit, which causes the electricity to stop flowing, and the light goes out.
Lights out! Lights out! Lights out!
It's really just that simple. We can place a switch in the circuit so that we can turn the light on or off using the switch. All the switch does is connect or disconnect the wires of the circuit.
Pinky, cut the red wire!
It may be helpful to think of electricity flowing through wires like water flows through pipes. Electricity and flowing water have several things in common, and a few major differences. The biggest difference is that electricity always flows at the same speed, which is the speed of light. So if you use water to conceptualize how electricity flows, be sure to imagine that the water is flowing at a constant speed. The things that electricity has in common with water is pressure, rate of flow, and resistance to the flow. Let's start by describing resistance.
Resistance is futile.
Resistance is a force like friction that works against the water flowing. For example, imagine a pipe with a rough inside versus a pipe with a smooth inside. It is much easier to force water through a pipe with a smooth inside because of less resistance. We measure electrical resistance with units known as ohms.
Can I get an ohm?
Next, think of pressure as the amount of force used to drive the water through a pipe. Again, remember that increasing the force doesn't mean we are increasing the flow speed. For example, imagine a semi-truck and a golf cart both pushing water along at the same speed. Since the semi is more powerful, it will be able to push water in spite of huge resistance. Meanwhile, the golf cart will fail to move the water if the resistance becomes too great. In electricity, we measure the amount of force with units known as volts.
Is 8,000 volts enough?
Finally, think of the rate of flow as being how much water actually moves. This could be determined by how big the pipe is. If the water always moves at the same speed, bigger pipes will move more water than smaller pipes. In electricity, we refer to this rate of flow as current, and we measure current using units known as amps. These three ideas, force, rate of flow, and resistance, are related.
They're related?
As we increase the size of the pipes, which is to say we increase the current, or we increase the amount of resistance, then we require more force, or voltage. There is an equation called Ohm's law which explains the relationship between these three things. Ohm's law says that the force or voltage is a product of the size of the pipe, or current, times the amount of resistance. Honestly, we will only use the ideas of force, current, and resistance a little, so don't be too concerned if it doesn't make complete sense at first.
It makes no sense.
But if you can understand how these three ideas interrelate, you'll have a good foundation for understanding electricity. One more note about electricity. When we use electricity powered by a battery, we are using a type of electricity called direct current. Direct current means that the electricity flows in a single direction, from the negative lead on the battery to the positive lead. However, the electricity that you plug into with a wall plug is called alternating current. Alternating current allows the electricity to flow in one direction for a very short period of time, and then in the opposite direction. There are good reasons as to why we use alternating current to power our homes and appliances instead of direct current, but I won't go into those in this video.
You gonna tell me the reason?
For the remainder of these videos, we will only deal with direct current. Check out the next video, where we'll build on these ideas to discuss a very simple circuit. Also, subscribe and click the notification bell so you can be notified of future videos.
I'm supposed to watch.